These are the financial applications of logarithms notes. So first we need to talk about the first couple equations that we're going to use to find these different applications. So the first one is if you want to compute compound interest, you're going to use this formula. A equals P times the quantity 1 plus R over N raised to the T. Now a couple things. A is going to be the final amount after everything's been invested. So when you do this, then P is going to be the initial amount. So the problem is something like you have $1,000 to invest. You would use the $1,000 in for your p-value, and then A would be after it's been in the account for so many years or so many months, what the total amount in the account would be. The next couple things, the R is the interest rate that you have, and that's always written as a decimal. So if it says something like you get really awesome interest and you're getting 8% interest, what you would do, you're not going to put 8 into the equation for R. To change this into a decimal, you move the decimal point back 2. So what you would use for R would be 0.08. So it's a really important thing. It's a really easy thing to kind of overlook, but it's super important. The N is going to be the number of times the interest is paid, or in other words, the number of times the interest is compounded. And what that means is if you have an account that compounds monthly, that means that every month, at the end of the month, whatever interest you have earned on the amount that's in your account gets added back in to your total amount, and then you start earning interest on not only the initial investment, but you also start earning interest on the amount of interest that you've gotten. So say, for example, you have $1,000 in an account, and at the end of the first month you've earned $4 of interest on that $1,000. That $4 will get added back in, so on month 2, you're now earning interest on $1,004, which is just going to make your interest in your account grow quicker. And then, oops, I forgot something in this equation. Just realized this should be n times t up there in the exponent. Whoops. Okay, so n up in your exponent is the same thing as it is down in the fraction, and then t is going to be the time. So usually it's the amount of years, so t is your time. Something else I should mention about the n value. So n is the number of times it's compounded. So a lot of times you'll see annually, in which case you're going to use 1 for n. If you have semi-annually, you're going to use 2. Quarterly, you would use 4. Monthly, you would use 12 for n. And then last but not least, if you have interest that's compounded daily, you're going to use 365 for n. So just a couple things to keep in mind. The other equation that we're going to use for compounding interest is going to be the continuously compounding interest. That formula for continuously compounding is A is equal to P times E raised to the RT. So in this instance, P is still going to be your initial amount. Oops, if I can spell that right. Initial amount. E is a number. E is that irrational number, so it's that 2.7, and so on and so forth. And you're going to get that by hitting, if you have the 84, you're going to hit the second key and then the division key. And I just double checked that on my calculator, and when you hit second and division, on the Inspires it's going to be a little different, but if you need help finding it, let me know. E is going to be 2.71828, and then it keeps on going. But you're never going to need to use the decimal approximation of it. If you need E in the equation, you're going to actually make sure the calculator do that for you. R is your rate, just like it was before. And then T is your time, just as it was in the other equation. Okay, so the difference here is instead of at certain intervals, the bank taking your money and dumping it back into your account, this does it constantly. So as it continuously compounds, what that means is that every time you earn interest, so every second or whatever the case may be, is going to get automatically dumped back into your account to then start gaining interest on the new amount. So let's look at an example. The first one in the notes says the houses are saving for their son's college education. If they deposit $12,000 in an account bearing 1.5% interest compounded continuously, how much will be in the account when Declan goes to college in 18 years? Okay, so a couple things. When you first read it, you need to pick out which formula you're going to use. And in this case, it said the interest would be compounded continuously. So if it's continuously, we're going to use A equals P times E to the RT. So when you read this, it says that they're depositing $12,000. $12,000 is their initial amount. And the account bears 1.5% interest. So your rate is 1.5%. But remember, we need to adjust that and change it into a decimal. So I'm going to move the decimal back to. So what we're really going to use for R in our equation is 0.015. And then last it says how much will be in the account when Declan goes to college in 18 years. So that gives us our equation for time, or our value for time. So what we don't know is how much money is going to be in the account after 18 years. So A is equal to P, so 12,000. Remember, E is just a constant. So 12,000 times E raised to the rate, which is 0.015, times T, which is 18. From here, you would type this into your calculator. So 12,000 times E raised to the 0.05 times 18. So you should get that there will be, and go ahead and round, since this is money, we're going to go ahead and round to the nearest cent, $15,719.57. So definitely their investment grew. Over 18 years is not a huge growth, but interest rates really aren't that great nowadays, so it is what it is. All right, let's take a look at another one. On number 2, it says Mrs. Kraus wants to invest boatloads of money she has saved. For a 5-year CD, so a certificate of deposit, Discover Bank offers a 1.73 rate compounded daily, whereas Third Federal Savings and Loans offers a 1.74% rate compounded quarterly, which is the better option for her if she's going to invest $45,000. Okay, so we're comparing here. So I'm going to set up, we have Discover versus Third Federal. Okay, so for Discover, the rate is 1.73%. The time is that for both of them, we're going to use the length of time as 5 years. And the big difference here is how it's compounded. So for Discover, it's compounded daily, which means we're going to have to use N as 365. So notice in this problem, it didn't say it's compounded continuously, so we're going to have to use the other compound interest equation that we didn't use in the first one. For Third Federal, it says our rate is 1.74, so really not that different from Discover. Time is still 5 years. Now this one is compounded quarterly, so only 4 times a year does that interest going to be added back into the account. So look at here, if you look, the Discover one compounds more often, but the interest rate is a little bit lower, versus the Third Federal CD. The rate's a little bit better, but it only compounds 4 times a year, so only 4 times a year is that money getting dumped back in. So all you have to do is plug it into the equation. So in both cases, we don't know what A is. So A is equal to, now we're going to use that P times 1 plus R over N raised to the NT equation. So P is our initial amount. In both cases, it's $45,000. And then 1 plus your rate. You're going to adjust it back to a decimal, so 0.0173 divided by the number of times it compounds, so 365, raised to 365 times the time, which is 5. So you're going to take that, type it into your calculator, make sure you use parentheses, and be careful. For those of you that have the 83 that can't do the nice fraction button, you're going to have to make sure you put an extra set of parentheses around that fraction inside the parentheses, so just be real careful about that. But you should end up with $49,065. And again, we're going to round to the nearest cent, 71 cents. So that's what we end up with Discover after a 5-year CD. If we take a look at the Third Federal, we're going to use the same formula. So P is 45,000, parentheses 1 plus your rate, so bump it back to 0.0174, divided by the number of times it compounds, so quarterly, raised to 4, so the number of times it compounds, times your year, which is 5. Again, use your calculator. Just be careful. If you need to put extra parentheses around this, you do. Lost my decimal point. Okay. And then, once you calculate it, you should get A is equal to 49,081.09. So not a huge difference, but in this case, it looks like the better interest rate was what set the Third Federal apart, even though it didn't compound as often. So this is the better choice, because you're going to make $15.38 more. In another video, we'll do the last two equations, or the last two examples on the notes, so you can see how those work.